All right. Question number 9. So, here's the deal. These elevator problems are always weird. They always confuse me. So let's kind of be clear on something. You've got like the whole. I'm just gonna write this nebulously here. So you have like the machinery of the elevator doing whatever it does. And I would always want to do in these elevator problems, I'd always want to somehow make the machinery like, well, there's a pulley and there's motors and there's ropes and all of that matters for an elevator problem somehow. And I better figure out what's happening with the elevator. And the trick with elevator problems is this. You're only going to deal with two forces. I cannot emphasize that enough. With elevator problems, you're always going to deal with two forces. And in this case, let's actually draw those. So I'm going to have the mass. And what I'm going to have here is the first force is I'm going to have an upward spring force. And I'm going to have a downward gravity force. And I'm just going to illustrate 4 situations that really matter for elevator problems. Okay, so here's how it works. When Fs equals Fg, okay, the elevator, okay, you're either at rest or moving at constant speed up or down. Okay? That's what I wanted to say. So that's the first thing. Second thing. When Fs is bigger than Fg. Now, I'm calling it the spring force. They're going to give it a different name. I'm sure, and we'll look at that in a second. So when Fs is greater than Fg, the elevator is either accelerating up, that's easy, or, and this is the tricky one, it is going downwards and slowing down to rest as it goes downwards. And then the last situation, when Fs, the spring force, is less than Fg, the elevator is either accelerating down or, this is trickier, it is going upwards and slowing down to rest as it goes upwards. Those are the situations that we are dealing with in these elevator problems. Okay, that's the key. So let's see. Looks like they're calling the spring reading RA, RC, and RS. Okay, fine. So we are moving upwards. Okay. So let's be clear. Moving upwards. So as we're accelerating up, we need RA to be bigger than mg. At constant speed, RA equals mg. And at slowing down near the top, RS is going to be less than mg. So what are the rules? Well, using this little mini chart that we've kind of created on the fly, nope, nope. We're really left with these two choices. So it turns out RA is in fact bigger than RC, according to, sorry, this should be RC here. Because as we accelerate upwards, we actually need more force to yank the elevator upwards and gain speed than we do to have it maintain a constant velocity upwards, where the spring reading would balance the weight reading on the mass. So that's question number 9.